Hello, my name is Richard Moulds, and I'm on the product management team with the KMS service here at AWS. Today we're talking about AWS Key Management Service, both from the perspective of introducing the functionality to folks that are new to AWS or to individuals and organizations that might be trying to implement a broader encryption strategy across their data stored in AWS. I'll also be introducing a new feature that we launched last year at the reInvent show called Custom Key Stores, which allows you to take more control over how your keys are stored and how they're managed in KMS. That's an important question, so we'll be looking at whether or not it might be right for you to think about taking that extra level of control over your keys. When we think about protecting data, of course, there's lots more to data protection than just encryption, although encryption is certainly one of the pivotal technologies. Data discovery, data classification, spotting anomalies, data leakage prevention are all also other critical aspects of data protection. But today we're focusing on encryption, which is a subject that will often send people running for the hills. The idea of understanding cryptography and algorithms and key management can be a fairly scary subject. Today, I'm not focused on really the cryptographic aspects of key management. I won't be talking about algorithms and key lengths. Today, I'm really focusing on some of the issues and some of the questions that users might have in terms of trying to plan their deployment of encryption across AWS, and more importantly, to try to figure out how much attention they should pay to managing their keys and ultimately what levels of control they should put in place. So we'll try to address three basic questions as we go through this session. First of all, should you encrypt your data at all, which might seem like a blindingly obvious question to some people. If so, jump ahead to slide 6 or 7. When we think about encryption, we almost immediately should start thinking about key management. At the end of the day, encryption is just a bunch of algorithms. It's deterministic. What makes encryption interesting, what makes it powerful, is ultimately how we control the keys, the secrecy of the keys and the availability of the keys. So who should actually manage these things? Believe it or not, there are choices, and you should give it some thought. And then finally, how much control should you have over the actual key material? People get very passionate about their keys, and for decades, organizations have had very strict internal mandates and external mandates about how much control they should exercise over their key material. Some of those mandates translate fairly well to the cloud. Some of those mandates don't transition particularly well to the cloud, and a lot of organizations face the reality that they are living with mandates and requirements that might be out of step with the architecture and capabilities of moving to a cloud environment such as AWS. And a lot of organizations have to wrestle with the degree to which those controls need to be carried over into a cloud environment. So we'll start off thinking about whether or not you should encrypt your data. First of all, it's important to describe the different aspects of how you might use encryption. Even though the algorithms might be very similar between these different scenarios and use cases, the key management issues and the deployment issues become very different. So first of all, on the left-hand side, we think about encryption of data in motion or network-level encryption. Everybody's familiar, I'm sure, with SSL, TLS, encrypting data as it moves between either a client and a server or two machine instances, an IoT device and a central management station. It's essentially ubiquitous. If you're not encrypting sensitive data as it moves over a network, then you probably really ought to be, and you probably should be fixing that rather than listening to this webinar. If you're doing TLS data protection in AWS, then you should certainly be looking at AWS Certificate Management Service for managing the certificates associated with TLS, which is a notoriously painful problem to solve. In the center, we've focused on encrypting data at rest or storage level encryption. There's really two flavors of this. This is where we're encrypting data as it resides in a database, in a file server, on a backup tape, for example. Data, at the end of the day, spends most of its time at rest. It moves very quickly at the speed of light, and it's used maybe for milliseconds, every year. It spends a great deal of its time at rest, and it needs to be protected because obviously sensitive and confidential data stored in a known repository becomes a very attractive target for an attacker. We talk about really two types of encryption: client-side encryption, server-side encryption. Client-side encryption is when you encrypt data yourself before you send it to the storage environment, either using an SDK or in your own or using your own implementations. Server-side encryption is where the storage environment, S3 for example, encrypts the data as it receives it and decrypts the data as it replays it back to the requester. So oftentimes we'll think of server-side encryption as transparent data encryption. Data gets encrypted as it gets stored, data gets decrypted as it's retrieved. Typically pretty simple to deploy, and it's where we'll focus virtually all of our time during this session. On the right-hand side, we talk about protecting data in use or application-level encryption. This is where you're building application code actually into your applications, and you're encrypting data on the fly as you use it specifically within that application. This is more complicated to deploy. It means changing your application code. It means managing keys within your applications can be quite tricky. There are SDKs that AWS provides, in particular the AWS Encryption SDK, and there is also the CloudHSM service to enable you to use hardware security modules and traditional crypto APIs as part of a data in-use encryption strategy. So as I say, today we're focused primarily on transparent encryption, server-side encryption, data at rest. Whenever we think about encryption, of course, we've got to think about what other data protection and access controls are already in place. Within AWS, we have a very rich mechanism through the use of various policies to create a strong defense in depth strategy. So different policies, whether it's a role-based policy or a resource-based policy, in the case of this diagram, a policy attached to an S3 bucket, or whether it's a VPC endpoint policy where we're defining rules and accessibility depending on the nature of how a request can be made. But ultimately, you're looking at whether data should be accessible or documents should be accessible in this diagram by a given set of users or a given set of roles from various different perspectives, from the perspective of the role, from the perspective of the mechanism, and from the perspective of the resource being sought. Now, obviously, not all of these policies will necessarily be in place in every situation, and things can get very complicated very quickly because you can often have overlapping controls. And unfortunately, things can change. Different individuals, different administrators may be responsible for different policies, and it's hard to prove at the end of the day. It's one of the greater challenges, how to fundamentally prove that a particular individual or a particular role does not or does have access to a particular resource or document. Which is why we focus very heavily on scoping down permissions, the principle of least privilege, to ensure that those edge case situations are avoided to as great a degree as possible. When we add encryption to the mix, we're essentially adding a fourth layer of protection, so yet more defense in depth. So if everything's working, this is essentially just that fourth layer, a separate policy managed by a separate organization. It's a distinct policy, in this case managed by the Key Management Service, KMS, which affects the ability to access the key to decrypt a given element of data from a particular storage environment. So assuming you have approval from a role perspective to access a storage environment, in this case a bucket, through a particular endpoint, you still need policy approval to have access to the key to ultimately go and decrypt the data in this case. So if everything's working, we have a fourth line of defense. Of course, the value of encryption is that if everything's not working, if an attacker chooses not to come in through the front door, but chooses to come in through, I won't say back door because that has many onerous meanings in the context of encryption. But if the attacker essentially attempts to steal data by breaking the glass, rather than using the front doorbell, drive a truck through the wall, then encryption becomes literally the last line of defense. Encryption is, by definition, a default deny protection mechanism. Unless you have access to the key, no amount of access to the data will give you access to clear text information. And of course, over the last 2 decades or so, the newspapers are full of stories of exactly this situation. CDs being left on buses, memory sticks being handed over, disk drives ending up on eBay, as well as lawful disclosure, subpoenas, all represent mechanisms by which data could become available independent of the various other control layers that are put in front of it. Now, obviously, moving to a cloud environment, managed data centers, some of those accidental methods of data breach are greatly avoided, but still, nonetheless, encrypting the data gives you that confidence and comfort that there's a default deny approach being applied to your data. This is, of course, one of the main reasons why encryption has become one of the required, in some cases, mandated technologies from a data breach disclosure perspective and data privacy perspective. Regulators, governments, industry standards bodies love the idea that there can be a simple access, no access approach applied to data that can at least prevent the notion of data being accessible if that data is accidentally, inadvertently lost. Now, of course, if it were that simple, every bit of data in the world would be encrypted already, and the evidence from the fact that we are surrounded by numerous data breaches in the press indicates that data is not typically encrypted by default, and there's plenty of good reasons for that. Over the years, encryption has built up a pretty solid reputation of being slow and of being complicated and of being rather risky. At the end of the day, if an organization manages to lose the encryption keys that are used to protect its data, then that data is, of course, scrambled forever. That's a technique you can use for destroying data, but it's also a technique that unfortunately can work against you and make data irretrievable forever, data scrambling. Complexity becomes a huge issue, typically in a traditional organization. Companies will buy file encryption systems, database encryption systems, tape backup encryption systems, email encryption systems, dozens of different encryption systems scattered across a typical enterprise IT environment, typically coming from different vendors, managed by different people, applying policies in different ways, and even being auditable to different degrees. These are isolated systems and can become incredibly complicated to manage. Certainly, I'm sure many of you listening are familiar with the notion of encryption silos across an organization, moving data between those silos, establishing any sort of consistency across those silos from a protection perspective becomes very difficult. Over the years, there have been a variety of encryption appliances, the notion of crypto acceleration to try and overcome some of the performance issues, but still, nonetheless, encryption is perceived to be slow and painful and risky. The good news, of course, is that in an environment such as AWS, most of those issues have been dealt with. AWS is a pretty homogeneous place, defined set of services, interacting over a defined set of APIs, a large amount of consistency in terms of how encryption is applied, the ability to centrally manage keys in a resilient and secure service in the form of KMS, Key Management Service. That itself is tied to universal mechanisms such as identity and access management through IAM, secondary storage in extremely resilient data stores, so 11 nines of durability, and then a consistent audit trail capability through Cloud Trail. So in some ways, what encryption and key management in AWS represents today, would have been a pipe dream in most traditional enterprises. Getting to a situation where you could contemplate the notion of encryption by default and a single, central, organized, consistent key management infrastructure across the entire enterprise is essentially impossible in most traditional environments. In AWS, that dream starts to become a reality and is something that our customers can actually start planning for. So more than 50 or so AWS services integrate with KMS from a key management perspective. This is a current list. If you look on the KMS website, on the features page, you'll see a current maintained list of services that integrate with Key Management Service. So these are all services that allow you to own the keys that actually live in your account, managed by KMS. Most of the other services, there are 100 plus services in AWS, most of those other services also integrate with KMS to manage keys, and virtually all of those services offer encryption by default or encryption capability. In some cases, the service is managing the keys on behalf of the service, and you don't even have any visibility of those keys. We tend to describe it as a service-owned key. But these are the services that allow the keys that are being used to encrypt your data to be owned by you in your account and to be trackable and monitored and audited as being used in your own account and your own copies of Cloud Trail. So you can see that as months go by and new services are launched, they will appear on this list. You'll see some of these services are marked with an asterisk. There are a couple of different ways in which keys are managed within KMS, and I'll talk about that in a moment or two. Before we get into that, it's important to think about how keys are actually organized in KMS. And the most important thing is to get your head around the fact there's a hierarchy. There's actually quite a big hierarchy, but most of the hierarchy is internal to our own management systems. There's two levels of the hierarchy that are available and exposed to customers. There are what we call data keys and what we call customer master keys or CMKs. So data keys are the things that are actually used to encrypt your data. These are used within the various services that encrypt your information. Maybe it's an S3 bucket, maybe it's an EBS volume or an RDS instance. Maybe it's being used within the encryption SDK in your own environment or in your own EC2 instance. So data keys live local. Data keys are used to encrypt the actual data. But access to data keys is controlled by the master key, by the custom master key or the CMK. And CMKs live only in KMS. They never leave KMS. And they're protected and controlled through the use of hardware security modules or HSMs, which have been used for many years within enterprise to manage keys of all forms, signing keys and encryption keys. So the KMS service is built on a large fleet of HSMs, and CMKs are protected and stored and used only within those HSMs. So policies that can control access to decrypting data and can control access to data keys are ultimately enforced through the CMK. And when you manage keys in KMS, you're entirely focused on the CMKs. KMS doesn't manage any data keys at all. Data keys, in fact, are essentially unmanaged. We use a technique called envelope encryption, where the data key is stored in encrypted form along with the data that it is being used to encrypt. So when a piece of information is required to be decrypted, the data key is decrypted on request, provided back to the service in question, and the data is decrypted. It's an interesting approach. It avoids managing potentially millions or even billions of keys. Organizations with petabytes of data may only have a handful of CMKs. It would be completely infeasible to manage an array of data keys to support an entire organization. So envelope encryption is a standard. It's widely used across all of AWS and many other cloud services. It's also very useful for encrypting very large volumes of data and performing very high-speed encryption. Because the data key is local to the service, the data key can be cached by that service in some cases, particularly in situations where a particular service needs very rapid throughput, high-speed I/O operations, such as, for example, the use of EBS volumes in EC2. So if we look at how envelope encryption actually works, to give you a sense of how KMS actually deals with managing and enforcing policy around CMK, it's worthwhile just to look through a quick example of encryption, server-side encryption rather, in S3. So if we start with the Encrypt process, we're starting with some plain text data, a document, for example. We're providing it to the S3 service, and we'd like it to be encrypted. S3 reaches out to KMS and requests that a data key is generated. KMS generates the data key inside one of the HSMs that are part of the KMS fleet. The data key is encrypted by your CMK, according to a policy that determines whether or not you're even allowed to use the key to encrypt stuff. And the data key in plain text is provided back to S3, as well as an encrypted copy of that data key. And that data key is encrypted with your CMK, the master key that lives in your account that is under your control. S3 then uses the plain text data key to encrypt the data that you've provided to the bucket. S3 then throws away that plain text data key. That data key, at least in plain text form, is never retained, never written to non-volatile memory. The only thing that's stored is your encrypted document and the encrypted data key. And the only thing that could ever unlock that encrypted data key is the CMK, the master key that only ever lives inside KMS. When we think about decryption, reverse situation essentially. So encrypted data and the encrypted data key retrieved from the S3 bucket. S3 provides the encrypted data key back to KMS. KMS determines whether or not the user in this particular context is allowed to decrypt that data key using the master key, the CMK, according to policy. If yes, then the data key, the plain text data key, which has been decrypted in KMS using the HSMs that are part of the KMS fleet, the plain text data key is provided back to S3. S3 decrypts the data using the data key and returns plain text documents. So that's how envelope encryption works. If you really want to dig into the details of the cryptographic details behind this, then there's a pretty useful white paper. There'll be a link provided in the resources to this webinar called the Cryptographic Details White Paper on the KMS side. It explains all the nuts and bolts of how CMKs are generated, how data keys are generated, how CMKs are protected as they're stored, how they are backed up, and how they're replicated from a resiliency perspective across the different AZs within a region to ensure that those CMKs are always available. So hopefully I've convinced you that you should be encrypting your data. In the past, in a traditional enterprise setting, there were plenty of good reasons why you wouldn't encrypt your data, or at least why you would apply encryption very selectively to only the data you were required to encrypt from a compliance perspective or from a risk management perspective. But these days, I think in the AWS environment, the way that encryption is deployed essentially universally across the major services and the way that keys can be managed centrally in KMS, there's really no good reason not to encrypt the data. So the question now is, who should manage the keys? Managing keys is still a relatively complicated process. Somebody has to define these policies. That requires some effort. Organizations have an incredible amount of data of lots of different types, and there might not be a single answer for who should manage your keys. Within KMS, there's really two basic approaches you can take, what we call AWS managed master keys and customer managed master keys. Sometimes you'll hear AWS managed master keys referred to as default keys or service managed keys. So in the case of service managed keys, which is the easiest to think about, the key lives in your account. You own that key and you can see that key being used in your audit trails, and you can see that key through the KMS console living in your account or through the APIs associated with KMS. But you don't get to manage that key. The key is created on demand by the service. You choose to use encryption in S3. S3 will create that key in your account. Only S3 can use that key, and S3 controls the policy, typically a default policy, for how that key can be used. You can't edit that policy, and you don't get to delete that key. The good news is you don't get charged for having that key either. So every service would use a distinct key that would be unique to your account. Custom managed keys are where you really take ownership for that key. It's still in your account, but now you get to control its lifecycle, and I'll talk more about that in a moment. You create the keys in advance, you give the keys names, and you decide when you're using encryption in a given AWS service or whether you're applying encryption through the use of an SDK, you decide which key you're going to use. And you get to define the policy over how that key can be used. So two very important distinctions. If you're looking to simply check a compliance box to prove that encryption was used on a particular piece of stored data, then AWS managed keys might be perfectly good in most cases. If you're required to apply a policy, if you're required to apply some selectivity to how that key can be used, then custom managed keys are probably the way to go. But all other aspects of how those keys are actually used, the security properties of those keys are the same. Latency, performance, capacity are all the same. The durability of those keys are the same. The promises that we make to never lose your keys are the same. And the availability of those keys are the same. And whether you're using AWS managed keys or custom managed keys, all activity associated with using those keys is tracked in Cloud Trail. It's really about ownership and really about policy, not so much about the operational aspects. Those operational aspects are essentially the same, irrespective of the type of key you're using. So if we look at the AWS console, KMS console, top left corner, you'll see a distinction between AWS managed keys and custom managed keys. For those of you that are familiar with using the KMS service, you may have noticed that a couple of months ago, we actually introduced a new KMS console. Since its inception, the KMS console was buried in the IAM console under a navigation link called Encryption keys. Now it's a standalone console accessible by the main AWS console services page. So within KMS console, choose which types of keys you want to list. If you click on AWS managed keys, for example, you'll see a list such as this. It's a predictable list in a sense that all of the keys are easily identifiable. They'll have a key alias, which is essentially a convenient name for the key that matches up with the key ID. And the alias will say that it's an AWS managed key, and the service name will follow it. So it's pretty obvious which is the key that S3, for example, will attempt to use if you select AWS managed keys when encrypting data in S3. So why should you go beyond just using AWS managed keys, which at the end of the day is the simplest approach? The first and most obvious, of course, is controlling permissions. With an AWS managed key, you don't get to control this. S3 uses the key and only S3 uses the key, but that's it. With a customer managed key, you get to decide which users and which roles can actually administer the key, can decide what happens to the key's lifecycle, and you can control who can use your key. You can significantly reduce the scope of how a key can be used. For example, you could force a key to be only used by a particular individual for encryption, as opposed to decryption, for example. You can impose conditions about how and when that key might be used. You might define that a key can only be used for requests coming from a particular VPC or from a particular IP address. You can impose conditions, for example, where metadata can be attached to the request that may, for example, contain references to a volume ID in EBS. And unless that volume ID matches, then a decrypt request against that same key would be rejected. So there's a dozen or so conditions that can be applied as part of policy and enforced from a cryptographic perspective in most cases to control the use of those keys. You can delegate permission. There's a whole series of grants and granting capabilities that live within KMS, so you can delegate the ability for other accounts to use a key, and you can share access to keys across accounts and across applications. You might wish, for example, one account to be able to use a key to encrypt and a different account to be able to use a key to decrypt. You might want to have all of the key usage associated with a given application, whether that application was accessing data in a file store, in a database, or in an S3 bucket. You might wish to use the same key and the same key policy across all of those different repositories for a given application. So sharing keys across accounts and applications is something that's not possible with an AWS managed key, but is possible with a customer managed key. We define policies using JSON statements in a typical fashion. They look very similar to IAM policies. In this example, we are defining an administrator policy for a key, and you'll see the list of actions there: creating keys, describing keys, listing keys, deleting keys, tagging keys, untagging keys are all examples of how you might wish to administer it. In this example, we're defining how a key can be used. So here we're defining a role that can use a key, and we're stipulating that using a key in this case means encrypt, decrypt, re-encrypt, generate a day key. In this policy, we're going to a level and applying some constraints. So, for example, in this case, we're saying that a key can only be used by a caller from a different given account coming in through a particular defined service, in this case, EC2 EBS in a particular region. And that call can only use the key, for example, in this case, to encrypt data. So we're being quite specific here, and you can obviously layer in multiple constraints in a single key policy. In addition to saying policies, you might also want to manage your own keys because you might also need to control the lifecycle of those keys. You might need to be able to delete keys within KMS. AWS managed keys cannot be deleted. They are essentially managed by the AWS service. You don't get to delete them. You can see them in your account, but that's all. You might need to be able to disable and enable keys from being used. You might need to rotate keys, change keys periodically. In the case of KMS, we can rotate keys automatically on an annual basis, and you can choose to opt out of rotating keys. You might need to organize your keys if you have thousands of keys, and some customers have tens of thousands of master keys. Organize your keys by department, by application. You can use aliases and you can use tags to better categorize keys. Again, something not possible with AWS managed keys. And of course, you might want to use keys outside of the encrypting AWS services. You might want to use the AWS Encryption SDK, for example, in your own applications. And you can use KMS directly as an encryption service. You can send data to KMS and encrypt directly within KMS using your master keys. So again, only possible if you're using customer managed keys. To give you a sense of how relatively straightforward generating customer managed keys are in KMS, on the left-hand side, we have just a simple screen grab of the Create Key wizard from KMS. You click on the Create Key button from the Customer Managed Key list. You can see here 5 fairly straightforward steps. When you create a key, you define a name for that key. You can give it a description. You can apply some tags for that key. People often use tags to make it simpler to reconcile their bills. You can use tags to define keys and associate keys with different billing centers, for example, from a cost control perspective. You define which users and roles can administer the key. You can define which users and roles can use a key. You define other access, other lifecycle attributes such as key rotation, key enablement, for example. You get to review the policy, edit the policy, add more details to the policy, and then create the key. If, for example, you're in S3 and you're choosing to encrypt a bucket automatically, you get to choose how that key is managed, whether you're using an S3 managed key or whether you're using a KMS managed key. Hopefully you choose a KMS managed key, but I'm biased. If you chose AWS KMS as a source of key management, you'd be presented with a list of keys that are available for your use. If you had not generated any custom managed keys at all, then you'd be presented only with the AWS or the default managed key for S3. So you'd see a single key, AWS/S3. If you've generated your own custom managed keys in advance that you'd like to use as the basis of protecting your in this case, S3 encryption keys, then those keys would be provided in the list. You select which key you'd like to use and click Create the bucket in this case. I mentioned that all activity associated with CMKs, whether they be owned and managed by you or by the AWS service in question, is tracked in Cloud Trail. Here's an example of a Cloud Trail entry showing the API request, when it was made, which key it was made in reference to, what resource that key was, the action was applied to, the IP address, and the identity of the user and account, for example. So all aspects of key usage are tracked. So we've talked about why you should encrypt. Yes. We've talked about whether or not you should take a hand in managing the keys or whether you should rely on the service in question to manage that key on your behalf. Let's turn to the thornier topic of how much control do you actually need over the key itself, the actual key material and the actual life cycle of the key. So in addition to controlling the policy, some organizations have requirements to actually physically control the infrastructure. And again, this really comes from a historic set of controls that a lot of companies have that have used key management systems on-premise or have used hardware security modules, HSMs, maybe in for decades, and have internal policies that are written around the notion that keys shall not be shared inside organizations, keys shall be locked down in certain devices. And many of those compliance requirements and mandates are extremely hard to change. The challenge often becomes how do you apply them in the context of a cloud-based service. So it's important to first think about the key management lifecycle. So if you were to Google key management lifecycle, there are many, many different interpretations. Here's one that I find useful. It's pretty. Think about a key as living in sort of 4 stages. You define the key, you give it a name, you sort of declare its existence in the universe. You create the actual key material that lives beneath that key, which might change periodically as you rotate the key, even though the name of the key, the alias of the key, the policy of the key, the definition of the key might stay the same. The material might actually change. You'll use that key ultimately to do something, encrypt, decrypt in this case. Then you'll ultimately delete the key, make it useful and destroy it. Obviously, through all of that, you're storing the key, you're backing the key up, and at some point you might need to recover that key. Periodically, you might choose to rotate that key by recreating, regenerating new key material, and you might choose to disable and re-enable that key. You might choose to disable as a precursor to deleting a key. Disabling is useful because it's a powerful intermediate step before actually deleting keys. Deleting keys is a fairly painful process, or can be a fairly painful process. It's something that requires a lot of thought because obviously if you delete a key that's been used to encrypt something in the past, then that data becomes irretrievable. So disabling keys is a useful intermediary step before you build the confidence to actually go push the button and delete a key. So all of these steps exist and are performed within KMS. KMS is a fully managed service. KMS manages the backup and recovery of keys. KMS generates keys, KMS deletes keys, KMS can automate the rotation of keys, and KMS makes it possible to disable keys. And through the envelope encryption process I mentioned earlier, KMS enables data keys to be used across a variety of different services. Some organizations need to have more control over some or more of these stages of the key management lifecycle. So in particular, one of the aspects that we launched a couple of years ago now was the ability to import your own keys into KMS, or bring your own keys, sometimes the feature is described as. So if you have these requirements, then this is a feature that might be interesting to you. If you need to physically control how key material is generated, generating key material is not as simple as it might sound. These are long random numbers, and the measure of randomness is something known as entropy. Organizations have mandates about how randomness should be created, what controls should be placed on the degree to which keys demonstrate the required level of entropy. So if you have some of those requirements, you need to control how your keys are generated, you need to have control over random number generators, then import key might be a useful feature for you. If you need to be able to remove key material from KMS immediately, then import key may be useful. KMS obviously allows the ability for you to delete keys within KMS. We provide a grace period, and you can choose between 7 and 31 days for that grace period. But if you need to delete a key instantly from KMS, then you probably should import it in the first place. But because if you import keys, you control the ability to remove those keys on demand and to re-import those keys at some point in the future. Therefore, we retain those keys in volatile memory only. And if there was a major power outage incident in an AZ or in a region, then that key would be lost, and you'd be required to re-import that key. Some organizations see that as a positive advantage. Some companies have an actual mandate that they should retain backup copies of their own key material, either for the purposes of playing a role in ensuring the durability of those keys, or because at some point they may want to reintroduce that key material back into the KMS service. If it's important that you do import your own key, it's a fairly straightforward process. You define that key in KMS, you define the alias, you define the name of the key. You essentially create it as a logical entity within KMS. KMS will create a wrapping key and an import token that defines that key for you. You'll download that wrapping key and the import token into your own environment. You'll generate the key using whatever mechanism you're required to use. For example, you might be required to use an HSM to generate the key, the random bits. You'll encrypt the random bits using the wrapping key, and you'll upload that encrypted key material and the import token back to KMS. It will associate it with the key that you originally defined, decrypt that key material using the private component of the wrapping key inside the HSMs within KMS, and then use that key, make that key available for use in the normal way as it would for any other key in KMS. So once the key material has been imported into KMS, all other aspects in terms of how access to that key is governed, how policies are applied to that key, are exactly the same as they would be for any other keys that are generated inside KMS. So importing key is an interesting feature. It's widely adopted in certain sectors, organizations you can imagine, more regulated industries that have historic mandates and controls for key management encryption frequently use import key to satisfy some of those requirements. Some customers need to go even beyond the need to import keys. They need to actually physically control the locations and the systems that store those keys. They need to have direct actual access to the storage environment that their keys live in within KMS. So last year, I mentioned earlier, we launched a new feature called Custom Key Store. And what it means is that you can store your keys in a key store that you can control. In KMS is a managed service. The key store that we use in KMS, built around our own HSMs, is not something you can directly manage and directly access. It's a universal shared resource for all customers of KMS. But if you have a requirement specifically to store key material in a FIPS 140-2 level 3 validated HSM, then this might be an important feature for you. The HSMs that are used within KMS are validated to FIPS 140-2 level 2. In most cases, there are aspects of the HSM design that are designed for level 3, but the formal certification is for level 2. If you have a requirement for level 3, which is likely because you've employed level 3 certified HSMs yourself in your own on-premise systems in the past, then this might be an important feature. If you have an explicit requirement to store your keys in a single tenant key store rather than a shared multi-tenant key store, then this could be an important feature. If you require to be able to audit the existence and usage of your keys independently of KMS. So KMS obviously provides a rich audit trail through Cloud Trail of how your keys are used. But if you need an independent perspective, a second view, a second opinion on how keys have been used, then this feature allows you to have a separate audit path, in this case through the CloudHSM service, and I'll talk about architecturally how it works in a moment. And if you have a requirement to be able to remove keys from KMS, remove keys from the cloud completely without relying on KMS to do so, KMS obviously offers the ability to disable and delete keys. But if you need to be able to delete key material instantly without trusting KMS to do so, then this is a feature that, again, might be interesting and might satisfy your requirements. So there's a little bit of background. A custom key store allows you to use a CloudHSM cluster. This is a set of HSMs that you essentially rent by the hour. It's a managed service within AWS called CloudHSM. The HSMs that are provided under that service, you control. You have direct administrative access of those HSMs. You get to decide how many HSMs you have. You get to decide how they're organized. You get to decide which availability zones those HSMs are defined in. You can use those HSMs essentially as your own private dedicated key store under KMS. Your HSMs are used to generate those keys, are used to store those keys, and all key operations associated with those custom master keys are performed inside the CloudHSM instances that you control. So if you have a set of mandates that are built around using an internal on-premise HSM and the sort of controls that you're expected to have in that context, this is the type of functionality that might resonate with you. Once again, once a key's been generated in a custom key store, it's used by KMS in the same way. So, for example, encrypted data in S3 and the policy statements that might be written around access to master key controlling access to data in S3. All of that stays exactly the same. S3 or EBS or any of the other AWS services that are accessing these custom managed keys are blind to the fact the key is in a custom key store rather than the default KMS key store. So from a front-end perspective, everything's the same. From a usage and controls and policies perspective, everything is the same. The difference is that the key is stored in a physical store that you control rather than a store that is managed entirely by KMS. Here's a slightly more detailed view of the architecture. On the right-hand side, you can see the two primary components of the KMS service, which is the KMS front-end manager, which is managing the identities and the rules and the policies associated with each key in KMS, and the KMS key store, which is built using the KMS HSM fleet. Whether you're using a custom application, AWS SDK, or any of the services that integrate with KMS, then they are all talking through the standard KMS APIs in the front end. On the back end, however, you can create a situation where CloudHSM is made from a cluster of individual HSM instances within your own VPC, and a connector is established between that VPC, your own CloudHSM cluster, and the KMS Key Management front end. And your CMK is generated in the CloudHSM cluster rather than in the KMS backend key store. You can continue to use that CloudHSM cluster for your other applications if you choose to do so. If you already have CloudHSMs and you're using them to manage and protect keys on behalf of other applications, for example, you may be running in EC2 or even on-premise, using traditional crypto APIs such as PKSys11 or JCE, then you can continue to use the cluster to do so, as well as using it as a custom key store for KMS. If you're using CloudHSM for the first time and you're only using it for KMS, then that's perfectly fine as well. So the connector is something that joins the physical store of CloudHSM with the logical entity of the key in KMS. And you'll see as you go through the workflow for creating custom key stores, there is a step process to physically connect KMS to your CloudHSM cluster, and you can disconnect KMS from the cluster if you want to make those keys unavailable. Here's a logical perspective on the same thing. There's a KMS perspective, keys that are visible and aware to KMS. Some of those keys, if you're not using a custom key store, then all of your keys are protected and managed in the KMS HSMs. If you are using a custom key store, then some of those CMKs will be stored and protected in a Cloud HSM cluster, which you can independently view and manage and audit through the tools that are provided by the Cloud HSM service and that you might be using to manage your non-KMS Cloud HSM related keys. So you essentially get two perspectives on these different key domains. The intersection of the Cloud HSM perspective and the KMS perspective are your KMS custom managed key, custom master keys rather, CMKs, that are stored in your Cloud HSM cluster. It's actually simpler to use than it sounds. If you want to get started, again, navigate to the KMS console. You'll see a new entry when we launch the feature called Custom Key Stores. Obviously, the same functionality is available through the KMS APIs. Click to the Custom Key Stores page. If you already have a custom key store defined, then you'll see a list of your key stores. If not, then you can create a new custom key store. Again, fairly straightforward process. Once you have a Cloud HSM cluster established in your account, you'll be given a list of the available Cloud HSM clusters that are available to you. You'll provide the credentials to enable KMS to use that cluster to generate keys and manage keys on your behalf. And then you create the custom key store. So essentially, a custom key store is a logical entity within KMS and a physical entity in a Cloud HSM cluster. Once you've created a custom key store and you're now looking to create master keys in KMS, you'll click on Customer Managed Keys. Custom key stores only support customer managed keys. You can't use a custom key store to protect an AWS managed key. If you click on Advanced Options after you've entered an alias or a description, click on Advanced Options and you'll see actually the ability to either import a key as we described earlier, by checking the external box or by checking the custom key store Cloud HSM box. You can choose to use a custom key store. And then in the next step of the key creation process, you'll be asked to select which custom key store you'd like that key to be generated and stored within. But of course, by taking more control over how your keys are stored and how your keys may even be used, comes some shift in responsibility. KMS is a fully managed service. We don't expect users to play any role in managing the durability and availability of keys. We don't expect users to worry about provisioning the right number of HSMs. We don't expect users to play a role in determining the performance of the service from their perspective. We have default limits, and customers are perfectly welcome, of course, to request increases to those default limits in situations where they need to. But ultimately, customers don't need to manage the fundamental operational aspects of the service. If you take control and you start to import your own keys and even deploy your own custom key stores, then some of that responsibility shifts towards the customer. I mentioned that KMS obviously stores KMS managed keys and KMS generated keys in non-volatile memory for the sake of ensuring durability. If you import your own keys and you therefore have the ability to remove keys instantly from KMS, KMS therefore does not store those keys in non-volatile memory. A power outage in a given region or AZ can cause that key material to be lost, and we require you to be able to re-import that key material yourself. That means you need to keep backup copies of that key material in your own enterprise, in your own environment. That means you need to secure it as well, and it means you need to have a process that you can be confident is secure as you wrap that key and as you upload that key material back into KMS. So as soon as you start touching key material, it becomes your obligation, of course, to ensure the security of the processes that touch that key material. If you're using a custom key store, then there are even more aspects that require some thought. Because you have physical control over the data repository, the key repository, and you can control the connection between your Cloud HSM cluster and KMS, you can make keys unavailable to KMS in a number of different ways, both advertently and inadvertently. And of course, if you make CMKs unavailable to KMS, then your data is also unavailable across any other AWS service that is expecting to be able to use that master key. So somebody controlling your Cloud HSM resources could inadvertently render data that is being used by somebody, for example, running an EMR job, unavailable. You can cause your backups to be deleted from Cloud HSM. Cloud HSM gives you control over your backups. It gives you control over how many HSMs you have. You can reduce the number of HSMs to 0 in your cluster, which would make those keys unavailable to KMS. You can delete the backups of those keys, making them unrecoverable. You get to choose in which AZ your Cloud HSM instances live and how many instances you have. So you have some control over availability, and you also therefore have control over performance. And of course, you have to have roles within your organization that can actually manage Cloud HSM instances. Creating a Cloud HSM cluster is a relatively sophisticated process and is a security sensitive process. You need to have resources and controls available in your organization to ensure that you can do that in a secure, repeatable and auditable fashion. We have a blog. You can see the link on this slide, and it will be also included in the resources as a resources link for the webinar that describes in a little bit more detail some of the pros and cons associated with custom key stores. In some cases, there simply might be no choice. If you want to replicate the sort of controls that you have with on-premise HSMs, custom key stores is the way to go. And that's okay, because chances are you'll be familiar with managing HSMs and you'll already have in place within your organization the controls appropriate for that level of technology and infrastructure. So to wrap up, we started off this session asking 3 basic questions. Should you encrypt your data? Who should manage the keys, and how much control do you really need over the key material? Hopefully, I've given you a sense that the notion of encrypting by default So if there's any question, yes, you should be encrypting your stored data. In some cases, you'll be forced to, but there's no real reason why you wouldn't these days. KMS is a secure, durable service, but most importantly, it brings consistency in terms of defining policies, in terms of describing how keys can be used, in terms of auditing how keys have been used. KMS provides a vital, in a sense, backbone service within the AWS environment. The key policy, the resource policies associated with KMS can be used to apply some very sophisticated extra layers of access control. And as I mentioned before, if there are ever situations where you think that data may become available, having a default deny policy associated with access to keys can be extremely comforting. You can choose either a hands-on or hands-off approach. You can decide whether the AWS service in question is managing the key on your behalf in your account, or you can decide whether you're prepared to take a more active role in defining policy and managing the key yourself. We think there's a distinct trend, and really our guidance is to take control of the keys and manage them yourselves and become familiar with how policies are written. But obviously you have a wide array of data in your organization, and for a large proportion of that data, AWS managed keys, default keys, sometimes known as, may be perfectly adequate. KMS is a managed service. That's an important thing. We manage durability and performance and availability. We think the richness of our policy controls support the needs of the vast majority of customers. But we recognize there are other customers that have particular requirements, are subject to external mandates or internal historic controls that require them to control certain aspects of the key management lifecycle, and in some cases the actual physical store where key material is both generated and used and stored. With the launch of the Import Key feature and the launch of the custom key store, we think we've covered most of those cases. Of course, there are always edge cases in terms of requirements for control. We're always keen to hear about those requirements. But obviously, whenever we hand over control, there's a certain amount of responsibility, and in the case of custom key store, a certain amount of cost as well associated with exercising that level of control. Challenge comes to apply those controls selectively to the data and to the applications and resources that actually command the need for that level of control. We're certainly always interested to engage. I hope you found this session useful in terms of at least opening up some of these topics. Of course, this is described in far greater detail in the KMS documentation and security blogs. I hope you found it useful, and many thanks for listening.